Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. I've got a couple of announcements before we start the show. The O'Reilly AI Conference is also coming up, happening April 29th to the 30th in New York. It will give you a solid understanding of the latest breakthroughs and best practices in AI for business. Go to dataengineeringpodcast.com/AICon-new-York to register and save 20% off the tickets. Also, if you work with data or want to learn more about how the projects you have heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to dataengineeringpodcast.com/ODSC-East-2018 and register. Your host is Tobias Macy, and today I'm interviewing Roger Chen about data liquidity and its impact on our future economies. So, Roger, could you start by introducing yourself?
Hey, yeah, thanks for having me online with you. So, I've been interested in the area of data for quite a while now, and in many different forms and fashions. Originally as a double E electrical engineer by training, and then eventually as more of an applied physicist during my PhD research at Berkeley, and then subsequently as an investor in startups working within the realm of data, machine learning, and AI, and most recently in terms of starting our own company that we're founding around a data network.
And how did you first get involved in the area of data management?
Yeah, it's interesting. So I'd say the first kind of foray was actually when I was a research scientist. And this is when I was studying the field of nanophotonics. And, I think this is a common problem in academic research, just getting access to open science data, stuff that could augment your own research, stuff that feels very non-zero sum for everybody in a field, and kind of feeling the pains of not having enough seemingly access to kind of data, right? And that kind of was what first opened my eyes to the importance of data. And, it was kind of a weird windy road. That's too long of a story to tell here, but basically I ended up in the startup ecosystem pretty quickly while I was in graduate school, and ended up at a venture capital firm working full time right after my PhD. And sadly, as a venture capitalist, you don't go around investing in silicon nanophotonic companies all too often, and so that's when I kind of pivoted myself into thinking about data in the sense of software and machine learning and AI, since a lot of companies that were most exciting and interesting were emerging in that field, in that area. And that's when I really kind of really got into the area of data management as a focus area. And it's kind of funny too, because if you think about it, I kind of saw the same pattern and problems when it came to AI and data startups that I saw when I was a researcher myself, which is that there are just all these data silos that prevent you from making a progress that should be able to be made, right? In a sense that you could have great algorithms, you could have great ideas, but you don't necessarily have the data to train against or use to kind of fulfill and explore some of your ideas. And I just think that's an incredible problem to solve, and that's something that I'm kind of set out to do now as well too.
And so a little while ago, I came across an essay that you wrote discussing how the increasing usage of machine learning and artificial intelligence applications is going to result in a demand for data that necessitates what you refer to as an increase in data liquidity and a broader access to more fundamental data sets. So I'm wondering if you can discuss a bit about what you mean by the term data liquidity and some of the ideas that you were uncovering in the article in question.
Sure. I mean, when I think about liquidity, there's really two ways I think about it. One is obviously the notion of having data that can move freely between different entities in order to unlock discovery. and development and all sorts of innovation. But the other way I think of liquidity too is just it's a marketplace and finance concept, right? If you can create a marketplace where you have assets that are liquid, they tend to be healthier marketplaces where that asset gets to be shared, right? Which leads to productivity and growth. And one thing I just found that was really, from that perspective, a really interesting thing about the data ecosystem is that data is a world where there's a lot of illiquidity, right? You have a lot of data silos that prevent this kind of movement of data to spur progress. And, on the one hand, I fully understand that because I think, in this day and age, I think having proprietary access to data is a linchpin to maintaining a competitive edge as a business. But at the same time, I don't think that's true for all data. I think in addition to a company having proprietary data, there is plenty of data where fragments of data by themselves are not enough to create value for any, owners of fragments, and where data commons across a bunch of businesses can unlock value for everybody, grow the pie, if you will, for everybody. And in addition, to that, that having that data commons layer could actually even augment the proprietary data that some businesses might have. But in order for us to get there, I really do think it ties back to this concept of, one, mechanically, can you create liquidity in the sense that can we actually move data around and make it accessible and easily attainable? But other, do we have an ability to create the incentive layer, right? The ability to motivate and bring marketplace dynamics into this data ecosystem so that people want to trade data and exchange data.
Yeah, one of the common discussions is around the concept of data capital, or data is the new oil, where in order to be able to benefit from the data that's being amassed, you need to be able to refine it into additional data products. And there was actually a really interesting article I read a little while ago about some of the ways that Google Maps has been able to take that refinement to create the products, such as all of the area of interest information that they have in their mapping. So I'll add a link to that in the show notes. But I'm wondering if you have any thoughts or examples of the types of data that you envision as being foundational to multiple organizations that you would want to see consolidated into a data commons, and some of the problem domains that they might be applicable to.
Yeah, I think there's tons, and I'll just hit on a couple here. One I think is health data in general. I think right now there's a lot of outsized interest in the idea of personal health or precision medicine. And part of what's driving that is the rise of genomics and the ability to do low-cost sequencing. But what's interesting to me is precision medicine really only becomes a reality if you're able to unify data, right? It's this weird, it's almost ironic. In order to have a precise understanding of a person's, health disposition, you actually have to have broad understanding of human population data in order to train against, in order to make those sorts of discoveries. And, that's one form of data commons that I think would actually unlock all sorts of new products, whether they're drugs or otherwise, or even just wellness products. As well as maybe even create new industries. But to get there, again, you need to kind of get to that basic foundation of having enough access to enough critical density of genomics data, as well as phenomics data to make that possible. And then on top of that, I still think, whether you're a life science company, pharmaceuticals company, a biotech company, or wellness company of any other kind, you can still have your own kind of proprietary data sets that you build on top of those data commons, and let that kind of data commons unlock discovery of your own data set, right, within your own data set. Other things I think about, beyond healthcare is just what are the kinds of data that, if they were publicly crowdsourced and publicly available, would just create a lot of value for everybody by helping them contextualize whatever it is that they're working on, right? So let's use another example of, let's say, weather data, right? Like weather data should not be something that's proprietary, yet if it was something that was a public good and publicly shareable, could enable a lot of industries, right? Whether it's farming and agriculture or whatever else. And then the last thing I would actually put out there too is even just the notion of having the ability to have publicly accessible training data for AI. And that might sound funny or a little bit kind of idealistic, but I can give a very concrete example of that. I mean, if you think about what ImageNet and some of these other data sets have been able to do to help kind of spur innovation and results in that field, then you got to wonder, well, what if I can have, the ImageNet for all sorts of other data types, right? Whether it's for autonomous vehicles or natural language or whatever else, right? So, all these sorts of data sets, if you're able to create public repos to make them available for people to, train off of, I just think that can unlock tremendous progress on an academic level, on a research level, but also on an enterprise level as well, too.
One of the things that I was most curious about when I was reading your article is the idea of the different types of organizational and technical structures that can be built around this idea of a data commons. And so one of the most obvious is the idea of open data sets, which are proliferating as the storage capacity for those data sets becomes more accessible and less expensive, and also as there becomes a greater awareness of and push for it. But you also call out some other additional structures, such as having a sort of federated data set. So I'm wondering if you can just talk about some of the different ways that these commons data sets can be structured, both from the business side, the organizational side, as well as from the technical level of how the data is actually located and accessed.
Yeah, so I think it's a great question. I think there's certainly a lot of different models for sharing data. And, the way I break it down, there are kind of three buckets, but even within those buckets, there are so many different permutations of how you share or exchange data. But largely I do think there are three categories that capture it. I think one, there's just the open data movement, where the idea here is that we, collect data, crowdsource it, obtain it however we do, and we publicly contribute it to the internet for public consumption. And I think it's fascinating because, I think that kind of behavior and sentiment is very additive and unlocks a lot of value for everyone when they try to get that data. I mean, think about how many times you've just kind of gone on Google and snagged a free photo that people contributed, and hopefully, had a Creative Commons licensing for, and used it for a project of your own, right? I think the challenge with open data is that, it tends to be extremely unstructured and uncoordinated, right? And that's fine for a lot of things, but for large scale data training projects for, machine learning or AI projects, kind of like the genomics and precision medicine application I described earlier, having coherence, cohesiveness, and structure in large data sets really, really does matter. And that's where I think open data doesn't necessarily cut it. And I think part of the reason why is because people who contribute to open data projects, they do so really purely because, of this desire to kind of do good and to share. And part of the challenge of that is it means that it tends to happen once in these one-off kind of benevolent projects. But because of lack of ongoing incentive, they tend to kind of peter out and they tend to remain fragmented on their own. There's another model where I think you can get much more cohesive, large-scale, and sustainable, data sharing happening, and that's through the form of a data brokerage. And the idea here is a bunch of people will collect data that they think is valuable. They'll use that to exchange with other data sets, to broker deals with other companies that collect data, right? All kind of in a pursuit of profit, because as we kind of collect and aggregate and exchange this data, we can now resell this collective package at a higher cost. And frankly speaking, this is how a lot of the modern e-commerce world and the modern online financial world works, right? You have a lot of companies who actually take your click data from browsing around the web, or take your credit data from various applications that you've used, combine it with other data sets that they get, whether through procurement or otherwise, and use that to power new sorts of applications and products for consumers. And that works fantastically well for a lot of applications. However, the challenge with that is that it tends to be a little bit more of an opaque market and something that happens on the back. So, that opacity means that if you're one of these data brokers trading financial data, great. but if you're not, you don't really have access to that sort of data, right? I think the third category would be the idea of, what I think of as a data cooperative. And the idea here is, market publicly that this data cooperative exists, right? So it's not this opaque hidden thing that you have to be an insider in order to access, but something that's publicly available. But in order for you to be part of this data cooperative and to be able to get access to the data from other contributors, you yourself have to be a contributor. And I think that model is interesting because what it does is, it allows you to have everybody benefit from that sort of membership, mentality that gives access to not only your own data but everybody else's data, as a member of that cooperative. But it does so in a way that's publicly accessible to others who might want to join. But I think the challenge of the idea of data cooperatives is that there's a code start problem, right? So if you want to publicly invite people to share data, I think there's a little bit of a you first kind of mentality. And I think that leads to the notion of data cooperatives being hard to get off the ground, in the early days. And so I think, when I think about these three different models, open data, when I think about data brokerages, when I think about data cooperatives, they all have their virtues and benefits, but they also all have their challenges and drawbacks.
And the data cooperative in particular has the question of what sort of a governance model do you put in place of who is going to be in charge of providing the access to the data? Is there going to be any sort of metering involved between the companies as far as providing a certain amount of data gets you a certain amount of usage, or if somebody wants to be able to just pay to be able to access the data set without necessarily contributing additional information to it?
Yeah, that's a really great question. I think governance is probably really at the heart of a lot of these things, right? Like good governance, the sense of fair rules and a fair game is one of the best things that you can do to actually encourage proper data sharing. I think we've seen governance up to now come in the form of industry consortiums, for example, right? And it's worked pretty well for certain applications, right? So, for example, the Semiconductor Research Corporation forming a consortium between different types of semiconductor research and manufacturing companies, right? To think about what are the collective technology challenges they need to solve, what sort of knowledge can they share to help them all kind of move forward, even though some of those members might be competitors, because they recognize that everybody needs to benefit from solving some technical hurdle for them to all as an industry kind of continue to grow and progress. And I think if you have very, very strong governing bodies, which maybe they're comprised of a committee that is representative of the different members or however else, I think that can work well. But I think we're also seeing a new kind of governance model emerge now, which is exciting, at the same time kind of like scary, and it's sort of an internet first model, and that's the idea of using cryptographic protocol networks to govern that, where you have internet-based rules for saying what you get for what sort of contribution, and internet-based rules for saying whether or not you've properly contributed data that you said you have contributed. And just to be more overt, I think what's happening with blockchains right now and the ability to kind of coordinate efforts across different people when it comes to data projects is fascinating to me.
Yeah, that's one of the interesting things I've seen as well, is using the idea of blockchains and smart contracts and the idea of the decentralized authority being used as a means of managing the access to federated data networks so that you can verify that somebody who claims to have access is only gaining the access that they are entitled to and nothing more. So it in some ways prevents the sort of widespread abuse of a system, but it also can potentially, depending on how the smart contracts are implemented, provide some sort of imbalance in terms of the level of access that's available to people depending on their fundamental capability of being able to participate in that network, whether that's because of infrastructural issues where they're located or technical sort of acumen or anything along those lines. So it's in some ways more egalitarian, but in other ways it's just another way to potentially exclude people, whether on purpose or by accident.
Yeah, I think it's fascinating. I think, earlier I talked about how data cooperatives suffer from, a code star problem where different organizations might wait for the other to put in first before they're willing to contribute as well. And what I think is interesting about, about decentralized networks for this is suddenly you're kind of, taking trust in any single one organization going first. You're kind of taking that out of the equation, and implicitly there's still some trust in the organization that's creating the decentralized network. But really, what you're saying is this protocol is going to give financial remuneration and payout to people who are willing to take that first step, and usually in a way that rewards them more than people who follow later on. And so suddenly, I think you just kind of change the dynamic a little bit. You now give this carrot, to solve this code star problem around sharing, right? Because even without another participant coming in, you have some financial incentive for someone to actually upload their data into a network, right? So for me, it's a really, really interesting way to kickstart a new kind of network. And I also think it's a way to create, like you said, a very much more egalitarian model where not only where you don't have to just be, some sort of branded, trusted organization, but you really, as any small organization, unknown one, or even individual, you can have permissionless access, right, to be part of this data network and to profit off of it. But I do think that that itself also comes with a lot of challenges, right? I think one challenge with these crypto token protocol networks is the fact that you have to be able to design something that is egalitarian yet has the flexibility to evolve over time, right? So if you have a governing body that's a consortium of members, right, for some sort of industry, they might be able to recognize 3 years in that maybe something should be recognized more, maybe they should head in a certain direction, or maybe contributions should be readjusted in certain ways. And I think for protocol networks, that can be a challenge sometimes because you're literally kind of baking into software code how some of those things can be shaken out. But we're seeing a lot of interesting things happen, right? There's a lot of innovation happening right now when it comes to crypto token protocols, and a lot of people are figuring out ways to essentially create really, really market-driven, elegant designs that create that kind of elegant, egalitarian governance structure while still maintaining enough flexibility in them to adapt and evolve over time. So I'm just really excited about what that's going to unlock for data marketplaces, whether it's in healthcare or anywhere else for that matter, actually.
And one of the other challenges associated with having these common data layers, particularly the idea of a cooperative and even open data access, is the challenge of being able to store and transmit the data and the infrastructure required to do so, because particularly if there are multiple organizational entities who want to be able to take advantage of these sets, then it may create a fair amount of strain on the underlying hardware systems that are necessary for being able to provide that access. So I don't know if you have any thoughts on some of the design of the way that data is stored and distributed, and some of the sort of economic structure that's necessary to be able to support those fundamental requirements.
Yeah, so I think storage and transmission infrastructure, I mean, you can, sort of break that down into a spectrum, right? And on one end of the spectrum, you have local client-based end-to-end transmission, right? So this is literally local client as in your laptop, or maybe in put the local into quotation marks here, maybe your Dropbox or your Google Drive, things, storage units where you have personal ownership over, do end-to-end transfer of data that you locally store to whoever the recipient might be. So that's one end of the spectrum, and that's I guess more of the traditional model of how data is transmitted these days. And on the other end of the spectrum, I think we're seeing some exciting new technologies evolving around fully distributed storage, decentralized storage, right? The idea where maybe we can take that file, instead of storing it locally on your hard drive, we can chop it up into a bunch of pieces and put it out on the web for random hosts to kind of store. And then when the time comes to transmit it, we can resync that up and deliver that to the right place for computation. And I think basically what we're going to see is we're going to see an evolution from the former to the latter, right? The reason why is because I think a lot of the internet infrastructure is already in place for you to, store a file in the cloud or, on your computer and just ship it from point A to point B. That's ready to happen today. So in terms of scalability, in terms of pragmatism, I think that kind of data storage and transmission infrastructure will be realized in some of these early data networks. However, I do think over time, what I described around this kind of exciting notion of decentralized storage, decentralized transmission, and even decentralized computing will have to happen for some data sharing applications, if only because data privacy for certain applications is paramount. So for example, when it comes to health data, that's not the kind of data you want to just send out to anybody that wants access to it. That's not the kind of data you want to be replicated and disseminated across the entire web. And that's the kind of data where you would want some sort of decentralized network of storage as well as computation, so that you can run training algorithms against that kind of data set without ever seeing the raw data, right? And that kind of ties into what I'm seeing now as an exciting new trend. And I think this isn't like the next few years. I think this is the next decade or two trend, but I think it's an inherently very, very powerful trend, and that is the notion of secure multi-party computing, right? And I think and the idea here is that, again, we can have multiple clients, multiple computers, take chunks of a storage job or a compute job and split that up and compute that locally in a way that the output would resemble the same output that a single computer computing that data would have spat out, except all those local clients that computed it in a multi-party computing model never actually see the full raw data, and therefore the data in whole remains private. So that kind of new sort of storage and transmission infrastructure, I think, is kind of on its way. And I think part of that is just the fact that we have fantastic compute resources and cloud infrastructure that's going to enable that to happen more and more over time. So I'm just really curious to see, as that becomes a reality. And to be kind of clear here, I think there are a lot of technical hurdles before that can fully happen. But as that happens, I wonder what kind of interesting data sharing applications will emerge, right? Because now suddenly you can talk about the idea of sharing the most sensitive data and having confidence that that data will not be co-opted by someone else, right?
Yeah, and the whole idea of data privacy and cleaning data sets is a complicated and nuanced one because of some of the examples that we've seen where data sets that have been ostensibly scrubbed of personally identifiable information can still be used to actually find individuals within a large data set, even though there isn't any sort of address or name information, just because of the implicit biases or the implicit information that's fundamentally linked to the way that the data was created. And one of the interesting approaches that I've heard about in recent sort of months and years is the idea of homomorphic encryption as a way to try and prevent some of that, where you don't actually have any direct access to the underlying data because of the way that it's encrypted, but you can still run machine learning algorithms against it because there is enough data in aggregate to be able to actually gain some information from it. But when you want to then delve into the individual data points, there's no way to do that because of the way that it's structured. And then going to your point of the distributed data storage, some of the technologies that are interesting, and I'm curious to see how they pan out within the broader ecosystem, are the interplanetary file system for being able to do fully decentralized data storage where everybody can take part of the network, and then the DAT protocol, which is similar in terms of being able to distribute the data, but also has the concept of versioning, and currently is a write once, read many system where only one entity is able to actually update the data sets, and everyone else who's part of the peer network is able to just read what's published. So that's interesting as well from the concept of a data commons, where it's one way to ensure that somebody isn't inadvertently polluting the data set by accidentally writing back to it.
Yeah, I think both those projects are fascinating, right? IPFS, I mean, it's a real thing. Like people are using it. It's up and live, and it's hosting a ton of files as we speak. And Max Ogden, in his work at DAT, along with the rest of the team there, it's brilliant, right? Like these are core necessities in the world of data, right? For all sorts of different applications. And, I think as we start layering on other sorts of primitives alongside and on top of the capabilities that they've pioneered around, privacy or computation or this or that, I just think that will unlock and enable all sorts of exciting new applications where, data privacy and trust becomes a bit of, has traditionally been a bit of a hurdle, because you can now remove those hurdles, right? And it just gets to this notion of, man, if we can have this, centralized, what's funny, it's like this universal computer, because it's decentralized, handle a lot of these compute jobs in a way where we can, in a very high trust way, contribute any kind of data, no matter how sensitive to it, right? What are the sorts of things that we can get people to do, right? What sorts of research projects and what sorts of data can we get people to contribute, right? And I think we're just now seeing kind of early innings of that with projects like IPFS, like DAT, like Filecoin, and so forth.
And once we move into the near future where these common data sets are becoming more widely available and more prevalent and more robust, I'm wondering if you have any thoughts as to the types of businesses or products that are going to become possible, whether for smaller organizations or for organizations of a larger size, simply because of the availability of that data and some of the ways that it may impact the future trending and growth of global economies.
Yeah, I think there are lots of things that will be enabled from a business and industry perspective, but I think there are two that stand out in particular to me. One is just the idea of enabling data commerce, right? Now you can actually create this notion of a data marketplace. I think everyone talks about how data is an asset, whether they call it the new oil or whatever else. But for the most part, data has been this thing that kind of gets copied and pasted, and either you're an insider and you have access or you don't, sort of thing. But if we get to a point where we can actually get data to be publicly available, and for you to have a single place where you can kind of provably show that you have ownership and sell data to people that want it, I think that notion is incredibly powerful. This notion of ascribing data ownership and therefore being able to enforce profits and reward for being able to contribute that data when they're bought by certain people. I do think for data markets, the one hurdle though is that data replication, the ability to copy and paste still is an issue, but I think there are actually some very practical things you can do about that, which is one, just continue contributing data that is new, that always refreshes, right? Always refresh that data network. One kind of data that I talked about earlier is weather data. Weather data is always changing. It's streaming. It's real time. What are all the other kinds of streaming data sets that you can pipe together into this public repo? It doesn't matter if someone copied and pasted last week's weather data, because they're still going to need this week's weather data, and they're still going to need next week's weather data. And suddenly, I think the idea or the notion of buying data, right, as a service from that kind of thing is actually very viable. And then the other way to kind of refresh data is, just continue collecting new data that wasn't there. So in the case of precision medicine, are you continuing every single week to scale by bringing in not only new genomics data from new people, but for each person that's already part of this data network, you're adding new kinds of data, right? So now from genomics to phenomics to proteomics to all sorts of other health data per person, right? There are ways for you to continue to scale and refresh the data that's on a network to make commerce a viable thing. And then I think, so that's one is data marketplaces. Two, I think part two is just what happens because you have these unified data sets, right? And this is just where, as a biopharmaceutical company, I now have this incredible public resource where I can go and access and get this data that I couldn't get before and use that to contextualize my internal drug discovery pipeline, right? And create maybe blockbuster drugs that I just wouldn't have been able to discover or develop before without some of this contextual data, right? Tremendous applications in finance as well. I think tremendous applications in other areas that I think AI is ready to unlock as soon as there's enough data, right? Whether that's autonomous vehicles or natural language, right? And those will be that's interesting, right? Because those will be things that will fall out in almost an indirect way. Those will be kind of new businesses that come out in an indirect way from the fact that you will have these kind of public data commons that let people do the research that lead to some discovery, that leads to some other discovery, that leads to some sort of product in those spaces down the line. And yeah, so I think those are two kind of main things, and it's an incredibly exciting future.
And I think one other aspect too to the broader availability of these fundamental data sets is a new business oriented around data integration and data enrichment, where you provide value by having your own access to these underlying data sets and then having a means by which to combine them together to create a new data set that wasn't necessarily accessible by accessing each of them in isolation, similar to the Google Maps article where they were able to combine their Street View data with their satellite imagery to be able to provide these areas of interest because of the machine learning applications of each of the sets in isolation then being combined via another mechanism. So I think the area of data enrichment and integration and then selling access to those, secondary and tertiary data sources as well as another way that the broader access to data will create a new economically viable model for future businesses.
Yeah, it's fascinating. I want to tie this back actually to the earlier discussion about crypto networks, because if you think about crypto networks, there's a fascinating business model innovation that sort of occurred, right? In a sense that when it came to Bitcoin, you had a network of people who whose job is literally to mine Bitcoin, right? And in Ethereum and other networks, well, not yet for Ethereum, but in the future for Ethereum and other networks, having validators stake whatever cryptocurrency is part of that network in order to do validation jobs or other forms of work on that network. And it's fascinating to me because it spells out this new sort of business model where people could get paid for doing work that they previously would have had a hard time getting paid for, but is extremely valuable, right? So in the case of Bitcoin and Ethereum, maintaining this universal ledger that is relatively immutable, that people can build off of, right? And then I think what you hit on when it comes to data is, well, what if we had an ability to create a network of people whose job is to assemble these data sets? What if you had a network that could track contributions and more than that is full of people that are ready to be mobilized to crowdsource any sort of data that you want on demand, right? How incredibly powerful would that be? And that itself actually is an interesting new kind of economy, a new kind of business that you can get into. Like you could literally be a solo entrepreneur somewhere in the middle of the United States and realize, hey, I'm actually really good at getting all this data, and I'm really good at proving that this is the right data, and you can maybe make a living off of that. So we'll see. I mean, I do think like that is a lofty vision I'm supremely excited about. I do think a lot remains to be seen with how viable a lot of these token economies will be. But for me, on a rational level, it makes a lot of sense to give proper payout and compensation to some of these people who do this really, really valuable work, which in a traditional world kind of just gets captured in these free open source projects, but maybe in this new world can be captured in a free open source, in an open source project where they get, you know, their dues for the hard work that they put into that to kind of enable all sorts of other projects to build on top of that open source project, right?
And as a final question, I'd just like to get your perspective on what the biggest gap is that in the tooling or technology that's available for data management today.
I think it's incredibly important to remember in this day and age where everyone talks about AI and machine learning that, you know, proper data management is what's going to allow you to actually capitalize on great AI algorithms, right? And I think related to that, there is specifically a big gap I see now in having the necessary tooling and technology to be able to structure data in a right way, you know, for training purposes, right? I think that's such an incredibly important but underappreciated task that makes a lot of these models successful. And I think we're starting to see some early progress, right? I think there's you know, there's this work out of Stanford around the notion of data programming that I think is fascinating. I believe the project is under this open source repo called Snorkel, right? So the idea that now maybe we can programmatically take a bunch of data which might not be clean, might be unstructured in many different ways, but have a way to scalably, a framework to scalably go through it and figure out how to munge and structure it in ways that are appropriate to now run it through a model for training, right? To train a new model, right? And so I think that's something that ought to be solved in the near future. And I think when that does get solved, I think that'll unlock a lot of new capabilities in the machine learning world. And I think there are some people who are really smart who are working on it right now. So I'm excited for that.
Yeah, I definitely agree that the area of automatic dark data extraction and enrichment of data from domain experts is a very interesting and valuable subject area. And I actually had one of the members of the Snorkel project on a past episode, so I'll add a link to that in the show notes as well.
Oh, cool.
So with that, I would just like to thank you for taking the time out of your day to join me and talk about your ideas on how the future of the data economy might pan out and some of the challenges that we need to face in the near to midterm. So thank you for that, and I hope you enjoy the rest of your evening.
It was a pleasure. I had fun, and thank you very much for having me.